4.4 absolute value inequalities. There's two things really to remember. So we're going to put this in a number line. We're also going to write it as inequality notation and interval notation. So there's three different notations that we'll do for solving these types of problems. Hence, for remembering, if you have a less than, so these two right here is going to be an and if you have a greater than, then it's going to be an or. So greater, less than. It's kind of an easy way to remember it, but it'll be easier once we start doing some examples. So if we look at number 1, I'm going to set up two different inequalities. So I'm going to say that 4x plus 5 is greater than 13. I'm going to solve that. So 4x is greater than 8, and so x is greater than 2. Then I'm going to write a second equation where I flip the sign and I flip the inequality and I switch the sign. So I'm going to say 4x plus 5 is less than negative 13. So I made two changes here. I switched the sign and I switched the inequality. So I flip and I switch. So don't forget to do both. Then I solve. So 4x is less than negative 18. So x is less than negative 18 over 4, which reduces to negative 9 over 2. What I want to do next, and I think that this is easier, is I have two numbers. I'm just going to draw my number line like this. It's beautiful. And I'm going to plot my points at negative 9 over 2, which over here, and 2. You don't have to make a scale or anything like that. And so if I look at the inequalities, I have x is greater than 2, so I shade above that. Then it says that x is less than negative 9 over 2, so it's below that. So hence where you get the less than or greater. So if I were to write this, I would say that x is greater than 2 or x is less than negative 9 over 2. That would be inequality notation. So if I said write it in inequality notation, that is what I'd be looking for. I'd be looking for x is greater than 2 or x is less than negative 9 over 2. You could switch them. You could say x is less than negative 9 over 2 or x is greater than 2. So the order does not matter. If I said represent it on a number line, then I would want it to look like this. If I said write it in interval notation, then I would be looking for negative infinity to negative 9 over 2, parenthesis, union, parenthesis, 2 to positive infinity. So that would be interval notation. So there's three different ways that you can represent it. So let's jump down to, let's look at number 3, because this is a less than. I'm going to try and do one of each type of example. So I'm going to say x plus 2 is less than or equal to 6. So x is less than or equal to 4. And x plus 2, I'm going to flip the sign, so greater than or equal to negative 6. So I made two changes. I flipped the sign and I flipped the inequality. So x is greater than or equal to negative 8. So it's greater than negative 8 and it's less than 4. So when I put this on a number line, I have my 2 points. I have negative 8. Notice I have a closed circle because it's greater than or equal to, less than or equal to. I have a positive 4, and I'm going to shade the insides because it's greater than negative 8 and it's less than 4. So anytime you have a less than, you're always going to shade the inside. Anytime you have a greater than, you're going to shade the outsides. That's where I get the and the ors. So inside is and, outside is or. And so then if I were to write this as an equality or interval notation, this is inequality notation right here. If I wanted to write it as interval, I would say bracket, -8, comma, 4, close bracket. Now, when you are solving square root inequalities, I feel like square roots are always a little bit easier because you don't have to do it twice. And so, same rules apply. You're going to isolate the radical, so I want to get this guy by itself, and then you only have one answer. So I'm going to say the square root of x minus 3 is less than or equal to 3. I'm going to square both sides, so x minus 3 is less than or equal to 9. So x is less than or equal to 12. Only one answer. Number 8, remember, so the rules still do apply. If I divide by a negative, that means I'm going to flip the sign. So if I'm going to divide by -3, the square root of x plus 2 is greater than 15 divided by -3, which is -5. So then I square both sides, so x plus 2 is greater than 25. X is greater than 23. So number 10 is a little tricky, and you might see some like this. I will say you're maybe going to have to factor. I know that's kind of scary, but we're going to make it through. And so we won't have too many of those examples, but I do want to show you how we would solve number 10. So I'm going to square both sides first. And so when I do that, that means I have to FOIL. I have to FOIL because it is a binomial, meaning it has two terms. So on the left, I have 3x minus 2 is less than 2x minus 3, 2x minus 3. So when I FOIL, I'm going to multiply all the terms together. I get 4x squared minus 6x minus 6x plus 9. Combine the like terms. You can do this all in one step if you want to, and I'm going to encourage you to do this all in one step, but I'm showing you the long way. So 4x squared minus 12x plus 9. And I have this stuff over here. Now, in order to solve for x, I do need to get everything to one side. So I'm going to move this stuff over here, meaning I'm going to subtract 3x and I'm going to add 2. So when I have that, it's 4x squared. When I subtract 3x, it's minus 15x. And plus 2 would be plus 11. Then I'm going to, so it would be 0 is less than that. Now I want to solve, so I need to factor this. In order to do that, I'm going to show you a little shortcut, and we will get into this all next unit. So even if this doesn't make sense yet, just bear with me. But I do need, so my first step is I'm going to have my two parentheses. 11 is a prime number, which is nice, because you know that you'll have 11 and 1, or you could put 1 and 11. The order does not matter. Another thing that I look at is my middle term. My middle term is negative, and my last term is positive. So that means that both signs need to be negative, because a negative times a negative becomes a positive. Now, if my last term were negative as well, like if it said minus 11, then that would mean that one would need to be positive and one would need to be negative. But in this case, both signs are the same when you have plus in your last number. Now I need to figure out what is going to go in my first terms, okay? And so they need to, since my a value or this value right here is not 1, then you're not just going to have x and x. You're going to need coefficients in front of that. So my factors of 4 are either 2 and 2 or 4 and 1. Now you can just guess and check, and that's the method that I'm teaching you, and that's the method that works the best, in my opinion, than trying to do a box method, is guessing and checking. So I'm mentally going to guess and check. So I'm going to think, okay, if I put 4 and 1 here, so if I did 4 and then just 1, x, When I multiply that out, I end up getting 4x squared minus 4x minus 11x plus 11. Now that ended up working, which was great. If you tried 2 and 2, you would end up seeing that it doesn't work out. So guessing and checking is my suggestion of what to do. So 2 numbers that multiply to get 4 here and here, 2 numbers that multiply to get 11 here and here. So all of that, once I foiled it, once I have factored it, that is all greater than 0. So I just moved this over and put greater than 0, just because I like it on the right side. I think it's easier. Now when you're solving for x, you set this stuff in parentheses equal to 0. You should remember that from Algebra 1. But if you have forgotten, you set this stuff in parentheses equal to 0. So 4x minus 11 equals 0. So, or I guess greater than 0, since we are doing inequalities. So 4x is greater than 11, x is greater than 11 over 4. And then my second solution, x minus 1 greater than 0, x is greater than 1. So x is greater than 11 over 4, and x is greater than 1. This would be a pretty intense example. I wouldn't see something like that too much on a test. Could show up on homework. Would be maybe like a challenge problem on a test. But you should be responsible for knowing how to factor, just because you did learn that in Algebra 1 and you did do it as well in geometry. So factoring, you should know a little bit about how to factor. This is a difficult factoring problem, but you are or should be responsible for knowing how to factor for the test.